Hello students, welcome back to Chemical Kinetics. Here in this module, we will study a numerical based on isolation method. Very simple and very important. So let's take a look at the numerical. Consider the reaction 2A plus 2B gives 2C plus D. From the following data, calculate the order of the reaction. The data is given to us, concentration of A, B and the corresponding rate of the reaction. Also write the rate law of the reaction. So if you observe this carefully, you will see that we have been asked to find two things: order of the reaction, and we also have to write the rate law. So let's get started. We all know the equation 2A plus B gives 2C plus D. Here, when we apply the rate law, we get rate is equal to K into concentration of A raised to alpha into B raised to beta. We know that already. We also know that alpha plus beta, when added, it gives us overall order of the reaction. Now here we have the given data with us, concentration of A, concentration of B and the corresponding rate of the reaction. I want you to observe the first two rows which are being highlighted for you. If you observe it closely, you will see that concentration of B is a constant. And if you follow this arrow, you will see that concentration of A is being doubled. And whenever this happens, concentration of B remains constant and A is doubled, the rate increases by a factor of 4. So if we incorporate all these things in the rate law, we already know what is rate law. Concentration of B is a constant. Concentration of A is changing and correspondingly the rate of the reaction is changing, which means these are the two variables. If we take all the constant terms aside, we will get rate is equal to K dash into concentration of A raised to alpha, where K dash is nothing but K into B raised to beta, all the constant terms accumulated together. Now here if we take the alpha value as 1, the equation will become rate is equal to K dash into A raised to 1. And if we double the concentration of A, the equation will become rate is equal to K dash into 2A. So it's pretty obvious that in this case, the rate is increasing by a factor of 2. And that is not right. The rate should increase by a factor of 4. So let's try another value of alpha. Let's take alpha value as 2. Now here, the rate law will become rate is equal to K dash into concentration of A raised to 2. Here when we double the concentration of A, the equation will become rate is equal to K dash into 2A whole square, which means 4 into concentration of A square. So now I can say that the rate is increasing by a factor of 4, and this justifies the given data because rate has to increase by a factor of 4. So I can say with absolute certainty that the value of alpha is 2. And in the same way, we can also find the value of beta. Once again, we know the rate law, rate is equal to K into A raised to alpha into B raised to beta. We have the given data with us. Now in this given data, I want you to focus on the last two rows which are being highlighted for you. Here if you see, the concentration of A remains constant and the concentration of B, if you follow this arrow, the concentration of B is being doubled. And whenever this happens, that A remains constant and B is doubled, it's pretty obvious that the rate also doubles. The rate increases by a factor of 2. So we can incorporate this into the rate law. Now here in this rate law, it's pretty obvious that concentration of B and the rate are changing, which means these are the two variables. And the concentration of A remains constant. So if we take all the constant terms together, we can rewrite the rate law as rate is equal to K dash into concentration of B raised to beta. K dash is nothing but K into A raised to alpha. Once again, let's take the value of beta. If beta is 1, this is what the equation becomes. Rate is equal to K dash into B raised to 1. Let's double the concentration of B, and now the rate will be K dash into twice the concentration of B. That means the rate is increasing by a factor of 2, and that's exactly what we want. When the concentration of B is doubled, the rate should increase by a factor of 2, and this justifies the given data, which means the value of beta happens to be 1. Alpha is 2, beta is 1. Put them together and you will get the overall order of the reaction, that is 3. This is the first part of the solution. Now, we know the rate law expression. We also know the values of alpha and beta. So here, if we substitute the values of alpha and beta, we will get rate is equal to K into concentration of A raised to 2 into B raised to 1. Now, this expression is nothing but the rate law expression. We have just substituted the values of order in this equation. That is how you solve these kind of numericals. That's all for this module. See you next time. Till then, take care.